We'll start by reviewing our trucking company Ontology, which is centered around the trips our trucks make to move customer loads between terminals. The Ontology captures key business entities and the relationships and activities that enable us to serve our customers. I'm going to zoom in on the truck entity. Notice here that I've added a new entity to the Ontology critical events with a relationship. This is a Lakehouse table that captures a history of critical issues relating to our trucks. This data is sent to Fabric from sensors in our trucking equipment via our telematics infrastructure. Here we can see the key attributes of these events, such as the fault description, timestamp, and recommended action to address each fault. Let's explore how this streaming data lands in Fabric and how we use Fabric's real-time features to address critical faults as they occur. We've created a Fabric event stream to process real-time events. This is a visual, no-code stream processing workflow design environment. On the left, we've created an endpoint where events are sent. Fabric supports different protocols, including Event Hub, AMQP, and Kafka. In this case, we've configured an Event Hub endpoint. In the Events node, we can see a preview of events that have been flowing into this event stream. We can see that the events contain various mechanical faults, such as oil temperature and load limit faults. Because we only want to capture critical faults, we apply a filter to the stream. Any critical event is sent to two sinks. One saves critical events to a Lakehouse table that's connected to the Ontology. The other calls an activator that triggers an immediate action, which we'll look at in a moment. For the purposes of this demo, we've created a Python notebook to begin streaming events to the event stream we just looked at. Let's run this notebook. We can see events are being posted to the stream. Each critical event will be saved in the Lakehouse for historical reporting, but also forwarded to the activator for real-time processing. So let's take a look at the activator. As events are sent to the activator, we can see them highlighted in green in the table, and we can also see them on a moving timeline. Let's change the time frame to show only the last few minutes. Now we can see events moving across the timeline as they arrive. To trigger actions and workflows in response to real-time events, we can add rules. For example, we might want to send an email or a Teams message when a critical event is received, or in a fully automated system, we can trigger Fabric notebooks or Spark jobs. We can also use the activator to start workflows in other enterprise systems by triggering Power Automate flows. Finally, let's return to the Ontology to view the fault data. If I navigate to the Critical Events node, I can see a quick summary of critical faults occurring within our trucking fleet.